Hello everyone, today we're looking at the topic of ratio and proportion. And we're just going to look at how ratio is linked to everyday life, and then we're going to move on to how we simplify ratios as well. Now ratios are used in many different scenarios, for example, in terms of cooking or in terms of exchange rates. And effectively a ratio tells you or shows you how much of one thing there is compared to another. So you're literally looking at how different things compare to one another. So for example, in a recipe, you might have 2 eggs for 100 ml of milk and then some flour, or maybe 200 grams of flour when you're making a cake. For an exchange rate, you might see when you go to the bank or online that £1 is equivalent to 1.2 or $1.3, for example. So you're saying that this £1 is compared to $1.3. It's showing a comparison. But we're going to start really much more simple than this. On the left-hand side, I have some red counters and some green counters, and there's a relationship between these. We are saying that for every 4 red counters we must have 8 green counters. Now a ratio is always written with a colon, and we can have this as 4 and 8. And what this means is for every 4 red counters, there are 8 green counters. Now some of you may already know that we can simplify this, and we will come to this momentarily. The next thing I wanted to refer to though is when we talk about proportion. Proportion shows you how much of one thing there is compared to the whole, effectively. Now the whole is all of the counters in total. So if I said what proportion is red, well, red is 4 out of 12. So the proportion of red here is 4 out of 12, which we can simplify to 1/3. If I said what is the proportion of green, however, well, that would be 8 out of 12, which is equal to 2/3. So proportion is just telling you how much of something there is in comparison to the whole. Now, we did say that you can simplify ratios, and this occurs by dividing both numbers by the highest common factor. Some of you may actually already see that 4 and 8 are both divisible by 4. I can divide this side by 4 and divide this side by 4, and that gives me a ratio of 1 to 2. And what that means is for every 1 red, I have 2 greens. And we can see that quite effectively over here. 1 red, there are 2 greens. 1 red, 2 greens. 1 red and 2 greens. And we said to do this, you have to divide by the highest common factor. So common factor. Now there is another rule actually when you're simplifying ratios, and that is that they should be integers. When you simplify, you should be getting integers, which are whole numbers, as your ratios. Now we did see a moment ago that when you have an exchange rate, if for example, if you have £1 to $1.3, now that is a ratio. It's completely fine, but it's not a simplified ratio. Very key to understand that for exchange rates, you're having what we call a unitary method, because we're using how much £1 refers to tell us how many dollars is worth. But what we need to know is that when you're simplifying a ratio, it needs to be whole numbers. So we're just going to look at a few different scenarios on the overleaf here on the other side, and we're just going to simplify these down. So over here, we've got a ratio of 12 to 15. The ratio of 12 to 15 can be simplified because both numbers here can be divided by 3. If we divide by 3 and divide by 3 again, we end up with a ratio of 4 to 5. There are no other numbers that go into this, so we have fully simplified this ratio. Now 100240 has much bigger numbers. Now if you don't know what the highest common factor is straight away, you can simply divide by smaller factors until you can't divide anymore. So for 100240, we could divide both of these numbers by 10. If we divide by 10 and divide by 10, we end up with 100 to 24. Now 124 are both divisible by 2, so we can divide both of these by 2. Now some of you may see there are bigger numbers which we can divide by, and that's fine. But dividing by 2 gives us 50 and 12. And actually, once again, both of these numbers again are divisible by 2. So divide by 2 and divide by 2, and that gives us 25 to 6. Now there are no numbers, other numbers that go into both of these, so 25 to 6 is the final answer here. Okay, next up we have a ratio of 3.6 to 4.8. Now the issue here is that these numbers are not simplified because they are decimals involved. Now the easiest way to remove a decimal or to make a number an integer or whole number is to multiply both sides here by 10. If we multiply both sides by 10, we end up with 36 to 48. And what we've done there is we now have numbers which we can simplify again by dividing by common factors. Now the highest common factor of 36 and 48, I believe, is 12. You don't have to do it in this way. You could have divided by 2 or by 4 or by 6 or by 3. But eventually, if you divide both sides by 12, you end up with 3 to 4. And again, that cannot be simplified. Now the final one on the right-hand side, once again, shows us a ratio, but this time there are 3 numbers, and that's completely fine. You're allowed to have more than one number, or sorry, more than 2 numbers, because you're comparing 3 things here. And we'll show you this again overleaf. Over here, I've got 32, 16, and 22. A number that goes into all of these is 2. If I divide everything by 2, I end up with the value of 16, 8, and 11. Now, because I have 3 numbers here, although 16 and 8 have a common factor of 2 or 4, 11 doesn't. So I can no longer simplify this because 11 is a prime number. And effectively, that is how we simplify ratios. The very last thing I want to touch on now is if we look at this in terms of a real life example, if we bring this back to the very, very first page over here, we had some reds, we had some greens, and I'm going to add in a few blacks now as well into this. We're going to have a ratio of, we'll have 3 reds, we will have 3 blacks, and we will also have 6 greens. 6 greens. Now, something I didn't touch on previously, this is just the very last thing I want to discuss, is that if we are looking at a ratio here of red to black to green, red to black to green, the ratio here would be 3 reds, 3 blacks, and 6 greens. And we can divide all of these by 3 to give you, if we divide everything by 3, divide by 3, we can see 1 to 1 to 2. 1 red, 1 black, 1 green. 1 red, 1 black, 1 green. 1 red, 1 black. Sorry, 2 greens. But very, very key, very, very important thing to say is that I didn't have to use this order of red, black, and green. If I said I want the order of black to red to green, the ratio would have been actually the same in this case, because it still would have been 3, 3, and 6. So that would have been 3, 3, and 6. But if I'd actually said in this case, or one other case, if I'd said green to black to red, or red to green to black, this would again change the order in which we are doing this. This would become 3 reds, 6 greens, and 3 blues, or 1 to 2 to 1. So it very much depends on the order in which you are being asked to write down your ratio. So effectively, that is the topic of ratio and proportion as an introduction. Also with regard to simplifying. I hope it's made sense. If it hasn't, please leave a comment below or message me directly. Thank you very much for watching. Take care and goodbye.